if an equals to 1 plus 1 upon 2 plus 1 upon 3 plus so on plus 1 upon n minus log n, then prove that sequence an is a monotonically decreasing sequence. Prove that it is convergent. Solution: here an equals to 1 plus 1 upon 2 plus 1 upon 3 plus so on plus 1 upon n minus log n. So an plus 1 equals to 1 plus 1 upon 2 plus 1 upon 3 plus so on plus 1 upon n plus 1 upon n plus 1 minus log of n plus 1. So an plus 1 minus an equals to 1 upon n plus 1 minus log n plus 1 plus log n equals to 1 upon n plus 1 minus log n plus 1 upon n equals to 1 upon n plus 1 minus log 1 plus 1 upon n equals to 1 upon n plus 1 minus 1 upon n minus 1 upon 2n square plus 1 upon 3n square minus 1 upon 4n square plus so on, because log of 1 plus x equals to x minus x square upon 2 plus x cube upon 3 minus x 4 upon 4 so on equals to 1 upon n plus 1 minus 1 upon n plus 1 upon 2n square minus 1 upon 3n square minus 1 upon 4n square minus so on is less than equal to of 1 upon n plus 1 minus 1 upon n plus 1 upon 2n square, because 1 upon 3n square minus 1 upon 4 and 1 upon 3n cube minus 1 upon 4n e raised to power 4 is greater than 0, etc. equals to 2n square minus 2n into n plus 1 plus n plus 1 upon 2n square into n plus 1 equals to 2n square minus 2n square minus 2n plus n plus 1 upon 2n square into n plus 1 equals to minus n minus 1 upon 2n square into n plus 1, which is less than equal to of 0 for all values of n belongs to capital N. So an plus 1 minus an is less than 0 for all values of n, which implies an plus 1 is less than an for all values of n belongs to n. So sequence an is a monotonically increasing. Also an is greater than 0 for all values of n belongs to capital N. So sequence an is a bounded below. So an is a convergent.